In this video, we'll use Jest with the React testing library to write unit and integration tests for the app we worked with in the previous video. We'll use the render, cleanup, fire event, and wait methods from the React testing library, in addition to the get by placeholder text, get by test ID query functions, and the as fragment method for rendering snapshots. Let's begin. In the last video, we used the test utils from the React DOM library with Jest. While there is nothing wrong with using test utils directly, there are a few things we can do better. For instance, you have to set up a rendering surface manually to be able to render the component and test, and you have to configure a teardown as well. This is a lot of boilerplate for every single test suite that you have to write. As a result, you spend more time writing the implementation of the test than the actual test case itself. The second issue is that when finding elements to test, we use DOM selectors. So you'd end up using an ID or a class selector, for instance. The thing is, as a user, you find elements by their text labels. For instance, a button that says send mail or an input field that says add a task. This is more human-like behavior, which in a way is what the aim of a test is. CSS selectors, on the other hand, are implementation details and are not designed for testing. For instance, if your style sheet changes as a result of an overhaul, with new selectors keeping the function of the component same, your tests will fail simply because selectors have changed, whereas the function may still be intact. Aiming to solve these issues is the React testing library, which is a very lightweight library built on top of React DOM and the test utils, which allow it to render a DOM using JS DOM to render and test React components. It is powered by the DOM testing library, which is framework agnostic and can be used with Angular, Vue, and React through binding libraries such as the React testing library, which we are investigating here. In addition, React testing library draws from the test utils from React DOM as well. What it does is provide an easy-to-use interface through utility functions that let you focus on writing maintainable tests rather than spend hours in implementation details. In fact, the guiding principle behind this library sums it up all. It reads, the more your tests resemble the way your software is used, the more confidence they can give you. I should also mention here that this is not a test runner or a framework, but simply a set of helper utilities that help simplify the process of writing and maintaining tests. So we'll work with the same app that we did last time and we'll write the same tests, but this time we'll use the React testing library instead of test utils, so you get a fair comparison. You can download the app from the link given on the screen, or you can work with the same setup as in the last video. I'll begin by creating a folder named _tests_, which is our standard practice. Let's first write a test suite for the add_to_do component in a file named add_to_do.test.js. I'll begin by importing React. I'll also import the component that we're testing. I'll then import the render method and the cleanup method from the React testing library like so. This library, along with its dependencies, the DOM testing library, comes pre-installed when you use Create React App Toolchain, so you can begin writing tests without any setup. Now, the render method is used to render the app, and the cleanup is used to clean up afterwards, which involves tearing down the component and the simulated DOM nodes created for the test. In the last video, we did a lot of setup with the before each and after each methods to get a div in place, which we tore down later. Here, we just need the after each function, which should run the cleanup method like so. That's it, no setup needed. This means we can straight away write our test group. So let's use describe, and we'll then use the it function to write our test, which tests the contents of the input field using the onAdd prop. This will be an async function. Since we are testing the onAdd prop, we'll again use jest.fn to set up a mock prop handler function. Now, once we render the component, we need to grab a selector to the input field, which has the placeholder text as add a task. So let's simply use the get by placeholder text query selector from the render method like so. Simple, no? We did not wrap anything in the act method or write any complicated code. It should be noted that the render function here incorporates the act function internally, so you don't have to write it explicitly here. Now, here's our placeholder text, so we can simply use it as a regular expression with the get by placeholder text function to get a hold of this input field like so. We then have to simulate typing something in and pressing enter. In a nutshell, we want to play with events. So let's import the fire event utility function. We can then use it to fire the change event, setting the value of the input field like so. Next, we can simulate the enter key up event like so. This means we can now write our expectations just as we did in the previous video. That's it. This is a lot less boilerplate code and setup and is far more readable than before. Let's run the test. And it passes. Next, let's write our test for the status button component. Once again, we'll import React followed by the render, fire event, and cleanup methods from the React testing library and the component itself. We'll then build our describe block within which I'll create my first test, which says that it returns true when the status prop is false. Before building the test, we'll create a copy of this group where I'll flip the expected conditions. I'll start by creating the onDone mock function because we are again testing a prop function. Now remember the last time we wrote this test, we used the status btn class to select the div for running events and expectations. The trouble with that approach is that CSS selectors are not exactly designed for testing because they can change over time as the product evolves. CSS selectors are designed for styling elements. So for writing maintainable tests that deliver stable results, the React testing library recommends using special data attributes called test IDs. So for instance, here, while developing the component, I can add a prop named data-test ID and set it to a string such as status btn. This doesn't interfere or costs anything as far as React is concerned, but in terms of writing tests, this simplifies your life by a magnitude. Let's see how. Once I've added this property, I can use the getByTestID query selector to grab the element. This makes it very easy to select specific elements for testing. Just add the data properties during development and your components are test friendly from the get-go. No need to find or invent ways to select an element. Now I can use fire event to fire a click event and we can then use our expect and matcher functions to test the component. And this works correctly. You'll notice our second test also passes even though we have not written it. This is because an empty test will always pass. So let's copy all the logic from here and paste it down in the second test. And I'll flip the conditions. And since we are also testing for CSS consistency, I'll append the status done class name here as I'm expecting that as well. And our test passes with flying colors. Finally, we'll test our app component, which integrates multiple components and the use of an API for fetching data and storing data asynchronously. I'll create a file named app.test.js and I'll import our usual functions as always. I'll also import the app, and I'm going to take a shortcut and import the mocked API functions from the previous video. This is required for our app to be able to call the API functions without actually using a live API server. We'll also run the cleanup after every test. Now, let's first render a snapshot successfully. We'll render the app, and I'll fetch the getByPlaceholder text query selector and the asFragment function. The getByPlaceholder text function will be used to select the input field from the add-to-do component so that we can add a task, whereas the asFragment function will be used to fetch the document fragment, a rendered outcome of your component, which we can then snapshot. And since our component has asynchronous data being fetched after it renders into the DOM, we'll also bring in a function called wait, which allows your expect statements to wait for any mocked API calls to resolve before it runs expectations. This is incredibly useful here because without it, your snapshot won't contain any data that comes from a mocked API. This function can wait up to 4.5 seconds by default before it times out. We can use it with the await keyword. The wait function returns a callback, which should house our expect statement, where we'll invoke the asFragment method, and we'll use the toMatchSnapshot function as the matcher. Let's run this, and you can see a snapshot being written here containing tasks coming in from our mocked API. We'll now get hold of our add-to-do input field using the getByPlaceholder text query, and we'll invoke the change and key up events like so. And we'll again take a snapshot. And rightfully so, our second snapshot does contain the newly added task. I'm sure you can appreciate the simplicity that the React testing library brings to the entire process. By employing easy-to-use helper utilities, you write less boilerplate code and focus on testing components in a realistic manner, just as the user would actually experience. Now, going back a step, let's also take a look at Enzyme, which is yet another solution for testing React components with Jest as the test runner.